Greetings everyone. This is Dr. Kesavan Devarayan from Tamil Nadu Dr. J. Jayalalitha Fisheries University, Nagapattinam. The title of my presentation is Biodegradable Halochromic Optical Nose for Monitoring Spoilage of Seafood. These are the contents of my presentation. Let's start with the introduction. Throughout the world, people prefer fishes over other protein food. It's mainly because of its easy digestibility and uh, taste. In fact, most of the times we check the quality of the fish by sensory evaluation, such as by checking the skin of the fish, gills, the color of the gills, then the eyes. But when it comes to packed fishes, it is impossible to check the quality. In fact, people who prefer the fishes have difficulties such as the cleaning processes and the bad smell. Because of this reason, there is a opening for the industry of processed and packaged fishes. So when it comes to the packaged fishes, we won't be able to check the quality by simply looking at it, and we won't be able to touch the fish. In this sense, there is a need for a sensor. Most times when it comes to the sense, humans prefer the visual sense rather than the other senses. And it's mainly because we would like to put any data into visible form so that we can understand them easily. And along with the visual form, we like the colors also. When we talk about the colors, there is an important material called as chromic materials. Chromic materials are the ones which change their color depending on the external stimulus. When we talk about the monitoring of the spoilage of the packed fish, there are several techniques demonstrated at different point of time. Most of the cases, people use spectrophotometers, texture meters, image analyzers, colorimeters, and some of the electronic gadgets. All of them basically function on the concept of total volatile amines. These are the amines that evolve during the spoilage of the packed fish. In our project, we had a strategy that we should have a sensor that exhibit a visual data. For example, it should be a simple color change so that we can easily understand what happens within the package. Then our sensor should have a eco-friendly components, because when we talk about the packed fish, we are supposed to keep the sensor inside the package. The sensor should not contaminate the fish product, and in turn it will give toxicity to the consumers. So we should not use any non-eco-friendly components for this purpose of sensor. And also, the data we get from the sensor, we should not need any advanced skills. It should involve less skills so that anyone can easily understand. We won't need to interpret the data. And of course, the sensor itself should be economical one. Only then we can use it practically. And the sensor should be able to monitor the spoilage of the packed fish in real time. These are some of the factors we considered in this project. With these strategies, we formulated these objectives: to develop the halochromic sensor from biocompatible polymer and mixed indicators, to evaluate the sensing properties of the halochromic sensor for real-time monitoring of the spoilage of the packaged fish at different storage conditions, and then to check the recycle usage and biodegradability of the sensor. Materials and method. We started with preparing the halochromic sensor, MIPVA, using the mixed indicator that consists of bromocresol green, bromocresol purple, bromothiamol blue, and other in total 7 color changing indicators are there. We mix them together in with optimized condition, optimized concentrations. Then we casted it into a thin film by adding PVA. And this thin film was checked with the FTIR spectroscopy and TGA thermogrammetric analysis. The stretching vibrations observed for the mixed indicators clearly suggest that the halochromic thin film is successfully prepared. On the other hand, the The degradation patterns observed in the thermogrammetric analysis also suggest that there is a successful incorporation of the halochromic dyes. And this is the halochromic response of the mixed indicator MIPDA halochromic thin film. And the thin film, the raw thin film itself shows a light blue color which changes into a gray color when we expose the thin film to the ammonia. And then we also subjected the halochromic thin film for monitoring, real-time monitoring of the spoilage of the packed sheath fish. In Tamil, it is called as vanjanam mean. Okay, it's one of the commercially important fish, and people prefer it because of its uh, richness and bonelessness. At 0 hours, I mean starting of the experiment, we observed the blue color of the sensor. On time scale, the color fades and changes into the gray region, and at 24 hours, we can see that it's completely gray in color. At 48 hours, most of the film was completely color changed, and we also observed the interference of the moisture, because when fish spoils, it not only releases the volatile amine, it also releases the large quantities of moisture. We performed similar experiments at refrigerated condition and also in frozen condition, and the color changes were similar. We also checked the RGB values, so that if at all we go for any automatic monitoring machines, it will be useful. And we found that at the beginning of the incubation, all the three red, green, and blue values were decreasing, and then gradually increasing for after 12 hours. And after 24 hours, we found that the values were decreasing mainly because of the interference of the moisture. We also checked the biodegradability of the halochromic thin film through the soil test, and we found that the halochromic thin film sensor is completely degradable within 14 days of incubation in the soil, fertile soil. And we also checked the recycle usage of the thin film. We find that the color of the thin film can be reversed using the acid vapor, and it can be used at least for 3 times. And when we calculate the economy of the sensor, we find that the economy is calculated uh, in consideration with the cost of the material, manpower, time, and we found that for 1 by 1 square centimeter sensor used for a package costs only 1 rupee. In conclusion, we synthesized a halochromic biosensor mixed indicator MIPVA, and we confirmed its successful preparation by means of FTI spectroscopy, TGA, and the CAE lab values and RGB values. And the halochromic thin film sensor showed excellent result for monitoring spoilage of the packed seed fish. It shows color change from blue to gray, and it has a high biodegradability. It can be recycled at least for 3 times, and then it is highly economical. It costs only 1 rupee per package. Finally, I would like to mention that the developed halochromic sensor is highly efficient for monitoring the spoilage of the packed shellfish. It's economical, it's biodegradable, and recyclable. Thank you very much for your kind attention.